Introduction. Time, the fundamental dimension that governs our existence, has been a subject of profound philosophical and scientific inquiry for centuries. While our understanding of time has evolved through the lenses of relativity and quantum mechanics, renowned physicist Michio has recently made a striking assertion: time does not exist. This bold statement, backed by the groundbreaking discoveries of the James Webb Space Telescope, has sent shockwaves through the scientific community and sparked intense debate. A visionary, Dr. Michio Kaku, a theoretical physicist, stands as a prominent figure in the world of theoretical physics. Born on January 24, 1947, in San Jose, California, Kaku displayed an early aptitude for science and quickly rose through the academic ranks. He completed his PhD in theoretical physics from the University of California, Berkeley in 1972, specializing in string theory, an area of physics that seeks to reconcile quantum mechanics and general relativity. Kaku's contributions to the field of theoretical physics are manifold. He has been a proponent of string theory, a theoretical framework that suggests the fundamental building blocks of the universe are not particles but rather tiny vibrating strings. In addition to his academic pursuits, Michio Kaku has a remarkable talent for science communication. He has authored numerous best-selling books including Hyperspace, Parallel Worlds, and The Future of Humanity. Kaku's unique ability to translate complex scientific concepts into accessible language has earned him a broad audience, making him a sought-after speaker and television personality. His presence in popular media has played a pivotal role in bringing advanced scientific ideas to the general public. Kaku's vision extends beyond the confines of theoretical physics. He is a renowned futurist, delving into discussions about the future of technology, space exploration, and the prospects of humanity. The concept of time, a perennial enigma. The concept of time is deeply ingrained in human existence, serving as a fundamental dimension that structures our lives and experiences. It has been a subject of contemplation and philosophical inquiries since antiquity. Ancient thinkers like Heraclitus pondered the ever-changing nature of reality, famously stating that you cannot step into the same river twice. This enigmatic statement highlights the fluidity and impermanence that time seems to introduce into our lives. Throughout history, diverse cultures and civilizations have developed their own understandings of time. A paradigm shift, Einstein's theory of relativity. The turn of the 20th century marked a watershed moment in our understanding of time, with Albert Einstein's theory of relativity leading the charge. Einstein's groundbreaking insights challenged conventional notions of time as an unchanging and absolute entity. Instead, he proposed a radical idea: time is not a constant but a dynamic, relative concept. Einstein's theory of special relativity, published in 1905, introduced the concept of time dilation. According to this theory, the passage of time is not the same for all observers. It depends on their relative motion. The famous thought experiment known as the twin paradox illustrates this concept vividly. Imagine two identical twins. One remains on Earth while the other embarks on a space journey traveling at near light speed. Upon the space traveler's return, they would find that less time has passed for them than for their Earth-bound sibling. This phenomenon underscores the relative nature of time. Furthermore, Einstein's theory of general relativity, published in 1915, brought a deeper understanding of gravity's influence on time. According to general relativity, massive objects such as planets and stars warp the fabric of spacetime, causing the path of objects to bend as they move through this curved space. Michio Kaku's bold assertion: time does not exist. While Einstein's theory of relativity introduced a groundbreaking perspective on time, it did not outright negate the concept of time itself. Instead, it redefined time as a relative and dynamic entity intertwined with space. However, in recent years, Michio Kaku has taken Einstein's ideas a step further with his assertion that time does not exist. This assertion has raised eyebrows and generated intense debate within the scientific community. Kaku's argument challenges the conventional understanding of time by drawing on the principles of quantum mechanics and string theory. He suggests that the true nature of time is far more elusive and abstract than our everyday experiences would lead us to believe. To grasp Kaku's perspective, it is essential to delve into the realm of quantum mechanics. In quantum physics, time becomes intertwined with the concept of wave functions and probabilities. Quantum events unfold unpredictably, and the notion of a fixed past, present, and future becomes increasingly nebulous. This suggests that time as we perceive it may be an illusion, a human construct that emerges from the probabilistic dance of quantum particles. Furthermore, Kaku's exploration of time extends into the realm of string theory. In this theoretical framework, the fundamental building blocks of the universe are not particles but tiny vibrating strings. These strings exist in a multidimensional space, which includes dimensions beyond the familiar three of space and one of time. String theory postulates that our perception of time is an emergent property arising from the interactions of these strings in higher dimensional space. The James Webb Space Telescope, a revolutionary eye on the universe. The James Webb Space Telescope, JWST, often dubbed as Hubble's successor, is one of the most ambitious and sophisticated astronomical observatories ever constructed. Made in honor of James E. Webb, a key figure in the Apollo program, the JWST represents the pinnacle of space-based telescopes. Its primary mission is to peer into the cosmos with unprecedented clarity, unveiling the mysteries of the universe. Launched on December 25, 2021, the JWST embarked on a journey to its designated orbit, positioned approximately 1.5 million kilometers, about 930,000 miles, from Earth. Unlike the Hubble Space Telescope, which primarily observes invisible and ultraviolet light, the JWST specializes in infrared observations. This capability allows it to penetrate cosmic dust clouds, peer into distant galaxies, and detect the faintest signals from the early universe. Looking back in time. Implications for Michio Kaku's assertion. Now, let's bridge the gap between Michio Kaku's assertion and the James Webb Space Telescope. At first glance, it may appear that the JWST's mission is unrelated to the nature of time. However, it is the telescope's capacity to peer into the depths of the universe, back in time, that adds a layer of complexity to this discussion. The JWST's ability to detect light from distant galaxies that has traveled billions of years to reach us allows astronomers to study the universe's past. When we observe light from a galaxy that is, for example, 10 billion light-years away, we are essentially seeing the universe as it appeared 10 billion years ago. This phenomenon is often referred to as looking back in time. The implications of this capability for Michio Kaku's assertion are twofold. First, it highlights the intricate relationship between our observations of the cosmos and the concept of time. The JWST's observations offer us a direct window into the past, allowing us to witness celestial events that occurred billions of years ago. This temporal aspect of astronomy emphasizes the role of time in our understanding of the universe's history. While Kaku's assertion that time does not exist remains a bold and provocative claim, the observations and discoveries made by the James Webb Space Telescope have the potential to shed new light on this age-old philosophical and scientific enigma. The interplay between cutting-edge astrophysics and groundbreaking theoretical physics continues to push the boundaries of our understanding of time and the universe in which we exist. As we venture deeper into the cosmos, armed with advanced instruments like the JWST, the intricate tapestry of time may reveal even more astonishing secrets than we ever imagined possible.